This is about assignment, the design report that you need to write and hand out as part of this module. The content of this video is what is the weight of assignment, what is the maximum grade awarded, and when should be hand in. So those basic important information. Then what is it about? It's about design of the family house on steep slope with some additional explanation. And what should be hand in? Presented through the checklist. Of course, you can amend this checklist according to your preferences and according to your design. I would also like to see that you prepare questions that you might have to ask on Monday in a live session. This will be at 1 p.m. The examination structure for this module consists from two parts. One is design report and weightage is 30%, and the other part is written exam and the weightage of written exam is 70%. In a design report, you will be assessed the first and fifth learning outcome. This is geotechnical design and understanding of substructure and superstructure interaction. This is how it looks, the first page of design report. There is a module code 6202 CIV. The credit rating of this module is 20. And the weighting of this assignment is 30% as said before. The maximum mark available is 100. Deadline is on Monday, 15th March at 23:55 time. This is in week 25. Now you can already see on the left-hand side the family house that you are going to design. I hope that you are excited about this. It is quite futuristic shape. And as you can see, it's placed on a steep slope on a piles. So there is interaction of substructure, pile foundation, and superstructure, a family house. In this slide, I will give you some more explanation on a design of the family house. So what you should do is read the assignment that you will find it under assessments. Assignment is provided on 4 pages and you need to familiarize yourself that you will be able to understand what I'm trying to speak about on this slide, because I'm going quite into details and you need a full picture for understanding of it. So if you haven't yet, please go back and read the assignment first. The family house is designed on a steep slope. Now you can already see that it is designed on 8 piles. This is pile number 1, pile number 2, then pile number 3, 4, 5, 6, 7, and 8. V1 and V2 are boreholes, and I will return to boreholes later on. Now we are just focusing on piles. The distance between pile 1 and 2 is 5.2, sorry, it's 20 meters. The distance between pile 1 and 2, let's try to like this, it's 20 meters. Then the distance between piles from pile H3 till H8 in between is 3.6 meters. So the distance here is 3.6 meters. And here as well. And so on. The distance which is perpendicular from here to here is approximately 5.2 meters. If you're going to read the assignment brief, I'm sure you will understand which dimensions I am providing here. And now to the boreholes. Borehole V1 and V2 results are presented in those two tables. This is only the nomenclature, and it's expected that you as a geotechnical engineer will provide this information as borehole nomenclature according to the appropriate standard. So many students would ask, which standard should I use? You can use British Standard or Eurocode. It's up to your preference. It's up to what you learned at level 5 with ED. You had tutorials how to read boreholes. So now in advanced level, you might be able to provide borehole nomenclature in a way by the standard. Here is a lot of information. You have a depth classification, then SPT results, and all those properties. Probably you won't need to include everything into your boreholes nomenclature. Probably you won't even need to use all this information for your design. Now it's up to you. It's your research. I gave you a lot of data, and you need to pick what is needed, what is not needed. But all those results are real, and we are able as geotechnical engineers to get them from boreholes. So as it is mentioned here, so please use appropriate standard to provide borehole specification. Provide a proper design of your family house. That it's really up to you. What are you going to do? It's going to be your family house built from brick and concrete, or from wood and glass, and take your imagination. What I would like is that you keep just a floor plan. You can also slightly make it in a different way if you wish to do so, and those 8 piles. Please put the house on site of your preferences, um, so on a potential location, because as it is mentioned, as it is written in an assignment, this house was built by architect, and this architect would like to sell this design to other locations around the world. And you, now as an expert in geotechniques, should find one location where it would be possible to build this house and justify your selection. This can be anywhere. It could be in Spain on a seaside with a steep slope where you go on holidays. If you are just studying in UK and you are coming from abroad, it could be this in your hometown. So anywhere in the world. It might be difficult to find boreholes for your location, but I'm sure that you can make assumption of geological conditions. And the most important thing is that you can prove that you are designing this on a steep slope. And how you can prove this? Well, that you draw the profile, and for example, this profile is in this slide from A to this, uh, sorry, uh, this one here, A. And if you're going to draw this as a profile, you will get the cross section of this slope. This is the basic checklist. So you can add more, you can swap, you can delete, you can do whatever you wish to do. I took a lot of things from the assignment brief, but I will add also some more just to approach to the family design, how architects and geotechnical engineers collaborate. So what you will need to do is a house design. You need to think about the permanent load of the house that I mentioned before, so from what material the house will be built. According to your preference location, you need to think also about variable loads. So that means some wind, some snow if you're building in the mountains, and you will do some more research what can be additional variable loads to take into account. Then I'm going to continue with the marking scheme, where you're going to be assessed for a presentation. This is 10%. It is important that your report is clear, concise, and easy to read. It should contain all the vital information. Citations should be provided where appropriate in a Harvard style. I will return into this part at the end of this presentation, but now I'm going to focus step by step on all assignment components. The first one is establishment of potential ground types. You need to make assumption for the site. So you need to do assumption according to the boreholes provided in this assignment, or if you go further for your selected site. Again, it's completely up to you how you're going to design your house. is going to be designed for this ground type provided in the assignment or for your selected site. So if you are going to use the ground type provided in the assignment, please don't forget to include water table. It is specified that the level of the water table should be assumed, whereas SC is indicated as wet. With the reason I didn't tell you the full name of this classification, this is your task to do research and to make a proper ground establishment. You will need to provide a borehole nomenclatures according to the standard as mentioned before. So this could be for a given, or you can find already done borehole from a potential location, of course, if it is available. I know that in level 5 you have searched for those boreholes on the website from British Geological Survey. You can do the same again. And then you will need to provide a cross-section of the terrain. This could be one given in the assignment, as I mentioned before, with which is marked with AA. And of course, you will need to justify that you are building your house on a steep slope also for your location, and this is normally available from the map. And please focus on the ground type. Provide all additional information, parameters needed for calculation. So, did you find your potential location? If not, think about this. State any issues that might impact your design. State what, how was influenced your choice of design of the foundation type. What are there therefore implications for the design of the foundation type? So you need to answer on all those questions or give an explanation more into detail into this. So I put here two books. One is focusing on Eurocode and another one is Smith's Elements of Soil Mechanics. If you haven't read Smith's Elements of Soil Mechanics, please start it now. It was something that you were very exposed at level 4 and level 5, and for building up all these advanced geotechniques, you need to already know this book. And I also put the Eurocode 7. This is just a symbolic book, so it's not something that you really need to search for it. You have the Eurocode available on your reading list on Canvas. Yeah, just that I just want to emphasize on what you need to focus at this point. So on soil mechanics, that you will be able to calculate piles, and of course Eurocode, that you will be able to do calculations, and for establishment the ground type. These are the important readings. So if I continue, The 15% bring independent research. So you will do research all the time. So this requires that you demonstrate the extent of any investigation you have undertaken as the standards needing to be followed to design the foundation accurately. That means that you need to show how standard was used, which assumptions have been made, um, if you want, how you calculated every detail of your design, and you can include the graphs where you took any values of, and so on. The detailed design brings 40%. So you need to specify all likely loadings the foundation might be under. You need to specify the size, shape, and the nature of the foundation, um, everything in a detail. You need to provide hand calculations showing that foundation will be able to support all the forces necessary to appropriate European codes. You can use British codes or you can use Eurocode. It's up to your preference. So, if you ask me how I would calculate this family house, probably I would use Eurocode 7, um, and then I would search for design approaches, and I would make a decision there. But it's your research, it's completely up to you. And the most important thing is that hand calculations should be shown and scanned into the document and either be referenced in the main body or be available to be checked in the appendices. So if there will be no hand calculations, there will be a significant penalty on this section. And as you can see, this section has 40%. So please pay attention on your hand calculations. Do them correctly, precisely, do research, include everything what needed to get the final result. And as mentioned, it should be shown or proven, actually it should be proven that your foundation will be able to support the family house. And the final part is reflection. So, how has your thinking developed over the assignment? Are there any other design options that might be viable? Think about this part as well. Of course, you're going to focus on your design, but you need to see the bigger picture. So what problems may you encounter on site that you could affect the successful completion of the project? Again, about your preference, you can link this to your location that you choose. So as I mentioned before, it could be some location from area that you're coming from or from area that you went on holidays and so on. And the most important thing that you will need to answer is, are there any ways to mitigate those risks? Mitigation is very important in these circumstances, because you need to think about the problems and mitigations at the same time. So I would like to see if you can prepare questions to ask on Monday live session. And the final part is, before you submit, that you make a quick checklist. So the report shouldn't exceed 2,000 words. So writing concisely is a very good engineering skill. Your report should contain list of content, figures, tables, abbreviations if used, appendices if provided. The references should be provided in Harvard style, and list of references should be included at the end. Everything must be cross-referenced. Please write in a way as you are writing your dissertation. So name caption every figure, every table, explain with it within the text. Check if your handwritten or type up calculations are included. And if you included all the main parts of the report that are mentioned in a basic list, so I'm going just to summarize them here, and they are also summarized in the marking assessment criteria. So you should include establishment of potential ground types and assumptions of foresight, independent research. Oh, here is a little mistake. It should be detailed design and reflection. I corrected this slide, so you need to include establishment of potential ground type assumption foresight, independent research, detailed design, and reflection. So, congratulations, you are ready to submit via Canvas. Thank you for your time.